The National Electrical Code, or NEC, does not require automatic power disconnection in a raised floor area upon the activation of a fire alarm system triggered by smoke detectors within that room. Specifically, we need to examine Article 645.5 D3, which addresses information technology equipment and its associated wiring within these specialized spaces. While this section of the code mandates the shutdown of cooling systems upon fire alarm activation, it makes no parallel requirement for the disconnection of electrical power. This distinction is crucial for understanding the scope and limitations of the NEC requirements in this context. The NEC is a comprehensive set of standards designed to ensure the safe installation of electrical wiring and equipment. It is adopted and enforced by many jurisdictions in the United States and serves as a benchmark for electrical safety worldwide. However, it is essential to interpret its provisions precisely and avoid extrapolating requirements that are not explicitly stated. In the case of raised floor areas, which are commonly found in data centers, computer rooms, and other facilities housing sensitive electronic equipment, the NEC recognizes the importance of maintaining environmental control to prevent overheating and potential equipment damage. Therefore, Article 645.5 D3 specifically targets the shutdown of cooling systems to mitigate the risk of fire hazards associated with these systems, such as refrigerant leaks or electrical malfunctions. The absence of a similar requirement for power disconnection suggests that the NEC considers other factors, such as the potential disruption to critical operations and the availability of alternative safety measures, in determining the appropriate level of intervention. It is important to remember that the NEC is not a design manual and does not provide specific solutions for every possible scenario. Instead, it establishes minimum safety standards that must be met, allowing flexibility for qualified electrical engineers and contractors to implement customized solutions that address the unique needs of each installation. In the context of raised floor areas, the decision to disconnect power automatically upon fire alarm activation may depend on various factors, such as the type of equipment installed, the criticality of the operations supported, and the availability of backup power systems. Some facilities may choose to implement automatic power disconnection as an additional safety measure, while others may rely on alternative strategies, such as manual shutdown procedures or uninterruptible power supplies, to maintain critical operations during a fire event. These decisions should be based on a thorough risk assessment and in consultation with qualified professionals who can evaluate the potential consequences of both power disconnection and continued operation. Furthermore, it is important to consider the coordination between the fire alarm system and other building systems, such as the HVAC system, the emergency lighting system, and the fire suppression system. A comprehensive fire safety plan should address all aspects of fire prevention, detection, and suppression, and should be regularly reviewed and updated to ensure its effectiveness. In addition to the NEC, other codes and standards may also apply to raised floor areas, such as the International Building Code, the International Fire Code, and the National Fire Protection Association standards. These codes and standards may contain additional requirements related to fire safety, such as fire-resistant construction, fire sprinkler systems, and smoke control systems. It is essential to comply with all applicable codes and standards to ensure the safety of occupants and the protection of property. To further clarify the NEC requirements regarding fire alarm systems and raised floor areas, let's delve deeper into the relevant sections of Article 645. This article specifically addresses information technology equipment and is designed to provide tailored guidance for these unique installations. Section 645.1 outlines the scope of the article, stating that it applies to information technology equipment and systems in an information technology equipment room. This room is defined as a space primarily used for the operation of information technology equipment and that meets specific construction and fire protection requirements. Section 645.4 addresses the disconnecting means for information technology equipment. It requires that a disconnecting means be provided to disconnect power to all electronic equipment in the information technology equipment room. This disconnecting means must be readily accessible and clearly identified. It is important to note that this section does not mandate automatic disconnection upon fire alarm activation. It simply requires that a means be provided to manually disconnect power to the equipment. Section 645.5 addresses the supply circuits and interconnecting cables for information technology equipment. It requires that these circuits and cables be installed in accordance with Chapter 3 of the NEC, which covers wiring methods and materials. Section 645.5b addresses the grounding and bonding of information technology equipment. It requires that the equipment be grounded and bonded in accordance with Article 250 of the NEC, which covers grounding and bonding requirement. Section 645.5c addresses the marking of information technology equipment. It requires that the equipment be marked with its voltage, amperage, and other relevant information. And finally, Section 645.5d addresses the fire suppression systems for information technology equipment rooms. This is the section that contains the requirement for cooling system shutdown upon fire alarm activation, as we discussed earlier. It is important to carefully review all of these sections of Article 645 to fully understand the NEC requirements for information technology equipment and raised floor areas. In summary, while the NEC requires the shutdown of cooling systems upon fire alarm activation in raised floor areas, it does not mandate automatic power disconnection. The decision to disconnect power automatically is a design choice that should be based on a thorough risk assessment and in consultation with qualified professionals. It is also important to comply with all other applicable codes and standards to ensure the safety of occupants and the protection of property. Understanding the nuances of the NEC and its application to specific scenarios is crucial for ensuring electrical safety and code compliance. Consulting with experienced electrical engineers and contractors is always recommended when designing and installing electrical systems in complex environments such as raised floor areas. They can provide valuable insights and guidance to ensure that the installation meets all applicable requirements and addresses the specific needs of the facility. Remember, the NEC is a living document that is updated regularly to reflect advances in technology and changes in industry best practices. It is essential to stay informed about the latest revisions to the code to ensure that your electrical installations are safe, compliant, and up to date. In addition to the specific requirements of Article 645, it's also important to consider the general requirements for fire alarm systems as outlined in Article 760 of the NEC. This article covers the installation of fire alarm systems, including the wiring methods, circuit requirements, and equipment specifications. While Article 760 does not directly address power disconnection in raised floor areas, it provides important guidance on the overall design and installation of fire alarm systems. For example, Section 760.41 specifies the wiring methods that are permitted for fire alarm circuits. It requires that these circuits be installed using wiring methods that are suitable for the environment in which they are installed and that are adequately protected from physical damage. Section 760.45 addresses the power sources for fire alarm systems. It requires that fire alarm systems be powered by a reliable source of power, such as a dedicated branch circuit or a backup generator. The power source must be capable of providing sufficient power to operate the fire alarm system during a power outage or other emergency. Section 760.121 addresses the circuit integrity of fire alarm systems. It requires that fire alarm circuits be designed to maintain their integrity during a fire. This means that the circuits must be able to withstand high temperatures and other environmental conditions without failing. To achieve circuit integrity, fire alarm circuits are often installed using fire-rated cable or conduit. These materials are designed to resist the effects of fire and maintain the integrity of the circuit for a specified period of time. Furthermore, it is essential to consider the coordination between the fire alarm system and other building systems such as the HVAC system, the emergency lighting system, and the fire suppression system. A comprehensive fire safety plan should address all aspects of fire prevention, detection, and suppression and should be regularly reviewed and updated to ensure its effectiveness. When designing and installing electrical systems in raised floor areas, it is also important to consider the potential for static electricity buildup. Static electricity can damage sensitive electronic equipment and can also create a fire hazard. To mitigate the risk of static electricity, it is important to use grounding and bonding techniques to dissipate static charges. This can be achieved by using conductive flooring, grounding mats, and other static control devices. In addition to the NEC and other codes and standards, it is also important to follow manufacturers' instructions for the installation and maintenance of electrical equipment. Manufacturers' instructions provide detailed guidance on how to install, operate, and maintain equipment safely and effectively. Following manufacturers' instructions can help to prevent equipment failures and ensure that the equipment operates as intended. Finally, it is important to remember that electrical safety is everyone's responsibility. By following safe work practices and adhering to applicable codes and standards, we can all help to prevent electrical accidents and ensure the safety of our workplaces and homes. Consulting with qualified electrical professionals is always recommended when dealing with electrical systems. They have the knowledge and experience to ensure that electrical installations are safe, compliant, and up to date. They can also provide valuable insights and guidance on how to address specific electrical challenges. Remember, the NEC is a complex and evolving document. Staying informed about the latest revisions and interpretations is crucial for ensuring electrical safety and code compliance. In addition to understanding the specific requirements of the NEC, it is also important to have a general understanding of electrical theory and principles. This knowledge can help you to troubleshoot electrical problems, design electrical systems, and understand the behavior of electrical circuits. Some basic electrical concepts include voltage, amperage, resistance, and power. Voltage is the electrical potential difference between 2 points in a circuit. It is measured in volts. Amperage is the rate of flow of electric charge through a circuit. It is measured in amps. Resistance is the opposition to the flow of electric charge in a circuit. It is measured in ohms. Power is the rate at which electrical energy is transferred in a circuit. It is measured in watts. Understanding the relationship between these concepts is essential for working with electrical systems. For example, Ohm's law states that voltage is equal to amperage multiplied by resistance. Voltage equals amps times resistance. This law can be used to calculate the voltage, amperage, or resistance in a circuit if the other two values are known. In addition to Ohm's law, there are many other electrical laws and principles that are important to understand. These include Kirchhoff's laws, which describe the behavior of current and voltage in complex circuits, and the principles of electromagnetism, which describe the relationship between electricity and magnetism. By developing a strong foundation in electrical theory and principles, you can enhance your understanding of electrical systems and improve your ability to work with them safely and effectively. Remember to always prioritize safety when working with electrical systems. Always to energize circuits before working on them, and use appropriate personal protective equipment such as gloves and safety glasses. If you are not qualified to work on electrical systems, always seek the assistance of a qualified electrician. Electrical safety is a shared responsibility, and by working together, we can create a safer environment for everyone.